This video is going to cover section 3.5, symbolic arguments. So we start off by defining what an argument is and what a valid argument is. An argument consists of a set of statements called premises and another statement called a conclusion. So in other words, you're given some information and saying if this is true and this is true, this is true, and then you assume one, so therefore the conclusion must be the latter part of the statement. An argument is valid if the conclusion is true. So if the conclusion is true whenever the premises are assumed to be true, and it's invalid otherwise. Okay, so the best way to show this is with an example. So here's our first example right below. We have premise 1, if you study, you will pass the test. Premise 2 says that you studied. Okay, so therefore the conclusion is that you passed the test. So we're not going to talk about the validity, can't say that word, if it's valid or not quite yet. We're just going to go ahead and see how we can write this using our proper notation. Okay, so let's go ahead and label everything first. So let's say that if you study, so studying, let's call this S. Okay, and I also have studying right here. So S would be part of premise 2 also. And then we have you will pass the test. So let's go ahead and do that in a different color. So you will pass the test. Let's do that as letter T for test. And you also have it in the conclusion here. So if I were to rewrite this using mathematical notation, okay, you would have something like this. S implies, okay, T. So if S then T, so that's from our previous video on conditional statements. And then we have S on the bottom, you studied, so S goes right here. And the conclusion would be that you passed the test. So therefore, T. So all I'm doing is I'm rewriting these sentences in using symbolic notation. Now we're going to add a couple things to this to make this more official. So the way you write these is you start off with, just how I did it here, you write it out. And then you're going to have a line here and 3 little dots. Okay, those 3 dots mean, so this means therefore. Okay, and that's pretty much it. So this is the way you would write something like this using symbolic notation. Okay, now this is what you would call a symbolic argument, which is the title of this section. So yeah, that's going to be half the battle, just being able to go from the sentences to our symbols, okay? The second thing we're going to be doing today is showing whether or not this is valid. So let's go ahead and do another example like this first, and let's see if we can write it out. I think we have 2 of them. Okay, so we have our first one right here. If Lois Lane marries Clark Kent, and they already have the letter for us right there. So Lois Lane marries Clark Kent, that's going to be our M. Okay, then Superman will get a new uniform. So Superman will get a new uniform, and that's going to be U. Okay, so that's our first statement. Let's go ahead and write it out before we move on. So we have M implies U. If Lois Lane marries Clark Kent, then remember this part right here, this right here then means the little arrow. Okay, then Superman will get a new uniform. So that's our first premise. This is premise 1. So this is our first premise. Okay, the second premise is the next sentence, I'm assuming. Okay, so let's see. Superman does not get a uniform. So Superman does not get a new uniform, and I'm doing it in blue because I'm seeing Superman again. So, and it says does not. So this is probably going to be not you. Okay, so not you. It's not going to be you. Let's rewrite that. So not you. Okay. Therefore, so remember, therefore is those three little dots, so therefore is right here. So therefore, Lois Lane did not marry Clark Kent. And again, there's that did not. So then, therefore would be not M. And we just got to put our line here to separate this. Okay, so just to kind of go through this, our first premise was that Lois Lane marries Clark Kent, then Superman gets in a uniform. Superman did not get in a uniform, therefore Lois Lane did not marry Clark Kent. And this bottom part right here would be our conclusion. Okay, this part right here. Now, is this valid or not? Well, we're going to find that out in the next, I think, 2 examples. Okay, but this right here again would be our answer using symbols. So this would be our symbolic arguments. Okay, I think we have one more of these. Yes, we do. If we search the internet S, okay, so I'm going to go right into it. This one I'm going to try not to color code. So S, okay, and I encourage you to try it by yourself first. If we search the internet, we will find information on logic. So if we do this, then we get I. Okay, we searched the internet. So S is your second premise, your second sentence. Therefore, so line, therefore, we found information on logic. Okay, that's it. That's it for this one. Remember, this first part is the first premise. This is the second premise. And this one is the conclusion. And this right here is your answer, your symbolic arguments. Okay, we're going to go ahead and now show how to prove if it's valid or invalid using a truth table. Okay, so this can be found in your textbook as well. This is the procedure we use to determine whether or not an argument is valid. Okay, so the first part is to write the argument in symbolic form. So this is what we've already been doing. We've already been doing this part. Okay, it's the first 2 or 3 examples. Step number 2 is to construct a truth table that shows the truth value of each premise. We got to do each premise and the truth value of the conclusion for all combinations. So it's what we've been doing in the past sections, but now we're going to go ahead and include the premises and everything all together. Okay, number 3 is your key thing here. If the conclusion is true in every row of the truth table, okay, in which the premises are true. So in other words, premise 1 and premise 2 have to be true, okay? The argument is valid. In other words, you kind of want like a true all across. If the conclusion is false, okay, in any row in which all of the premises are true, the argument is invalid. Okay, so for false, we look at the conclusion. If the conclusion is false, but the 2 premises are true, automatically it's false. And that can happen in any of the rows. So here's an example just to kind of look at so you can see how this works. We have this premise, H implies M, H, therefore M. So what we did is we got our H, so all of our H's, okay, here's H, and we took M as well. And we put that right next to it. So it's kind of like our P and our Q. Okay, it's kind of messy, so I'll leave it like that. So it's kind of like our P and Q. We put all the combinations, so true, 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 false, false, true, false, false. This is just like before, okay? And then we're going to go ahead and do the first premise and the second premise. So the first premise was this one, H implies M. So that one goes right here, okay? And remember that for P implies Q, we did this previously. This is always going to be true except, so it's true except when you have P true and Q false. So in other words, when the first one is true and the second one is false, this is false. So if you look at that right here, let's see, true, true, true. True, false, there's our false. And everything else is true. Okay, so that's the first premise. The second premise is just H by itself. So all we have to do is look at H right here and copy it. So true, 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 false, false, and false, false. We literally just copy pasted it, okay? And finally, the conclusion is M, so it's another copy paste. Here's M, we transfer it over here. So these values are the same as these values, okay? So with that in mind, we look at the rows now. So this part right here, I'm gonna do it in green. This is what we're looking at in the end. Okay, we need to see if we have truths anywhere across, and we do. We have it right here in the first row. So therefore, since we have row 1 all true, this would be considered a valid argument. Okay. Now let's say, for example, this had been a false, then that would automatically make it invalid, because if you have true, true anywhere in these two sections right here, but you have a false over here, the entire thing is false. So if you look at the other rows, we have false, true, true, false, true, false. We don't have any more true truths. Therefore, we're okay with it and it's valid. Okay, a little bit different than what we're used to, but we're going to go ahead and try one.